West of Loveland, Colorado, something extraordinary has been taking shape. For 4 years, construction crews have been building the largest new dam in the United States in a quarter century. The Chimney Hollow Dam stands 350 feet tall, contains 22 million tons of rock, and will hold back 29 billion gallons of water when complete. This $584 million project represents decades of planning and promises to secure drinking water for 800,000 people across northern Colorado. But getting here required solving problems that pushed American engineering into uncharted territory, bringing European technology across the Atlantic, and confronting a geological surprise that nobody saw coming. So stick around as we do a deep dive in this project, what it is all about, and why this is one of the most challenging projects ever. Let's get started. Colorado faces a peculiar problem. The Continental Divide runs north to south through the Rocky Mountains, creating a natural line where water flows either east or west. Most of the state's water exists on the western side as snowmelt running down mountains and collecting in rivers. Meanwhile, most of Colorado's people live on the eastern side along the Front Range. Cities like Denver, Loveland, and Greeley sit on the dry side of the divide, and their populations keep growing at staggering rates. 8 of the 10 fastest growing communities in Colorado are located in the northern region, and population projections show the area doubling in size over the next 2 decades. To solve this geographic mismatch, water managers built the Adams Tunnel decades ago. This 13-mile tunnel cuts through Solid Mountain, bringing water from the western slope to the eastern communities. But there's a second problem that's just as challenging. The water arrives when it's least needed and disappears when demand peaks. Winter snowmelt creates abundant supply during cold months when consumption drops. Summer brings heat, lawns, agriculture, and industrial needs. But that's when natural water flow decreases dramatically. Storage becomes the only answer. 12 northeastern Colorado water providers joined forces to create a solution that could serve approximately 800,000 residents from Broomfield to Greeley and everywhere between. The Chimney Hollow Reservoir will capture 90,000 acre-feet of water and release 30,000 acre-feet annually to communities throughout the year. The project also includes a partnership that committed $90 million to Western Slope Water Resources, addressing concerns about taking water from one region to serve another. Every earthen dam needs an impermeable core to prevent water from seeping through millions of tons of rock. Traditionally, engineers use clay because it's naturally waterproof and widely available. Chimney Hollow's site had plenty of rock, but not nearly enough clay for a dam this size. The engineering team needed a different solution, and they found it in the Swiss Alps. Wallow, a Swiss contractor with 86 years of experience, developed asphalt-core technology precisely because alpine regions often lack sufficient clay deposits. They perfected a technique using hydraulic asphalt, which differs completely from the asphalt on roads. Road asphalt contains air voids by design to allow drainage and prevent ice buildup. Dam asphalt eliminates every void, creating an absolutely impermeable barrier. Hydraulic asphalt remains flexible and possesses self-healing properties, unlike brittle road asphalt that cracks under stress. Wallow brought their specialized machine from Europe specifically for this project, because only a handful of these machines exist worldwide. The process works like a giant 3D printer building the dam layer by layer. The machine begins each pass by heating the previous asphalt layer with infrared to restore its temperature to optimal bonding conditions. Then it lays down a fresh 9-inch lift of asphalt mix, heated to 350 degrees Fahrenheit. This special mix contains extremely high oil content to ensure zero voids. As the machine advances, it simultaneously places Zone 2 material on both sides of the asphalt to keep everything precisely aligned. Small rollers follow immediately behind, compacting both the asphalt core and the adjacent filter material. The asphalt core measures just 2 feet wide, but will hold back 3 miles of water extending across 740 acres. Construction crews repeated this process more than 500 times to build the core from the foundation to the crest. When fresh asphalt hits the surface at 350 degrees, you can hear water crackling as it evaporates instantly on contact. The visual looks almost gelatinous compared to typical road surfaces. This technology transfer from European alpine construction to American water infrastructure represents one of the most significant engineering decisions of the entire project. Without it, Chimney Hollow couldn't exist in its current form. But laying asphalt was just one piece of a construction puzzle that demanded moving mountains on an almost unimaginable scale. Barnard Construction made a bold promise before breaking ground. They would dump one truck loaded with rock every 2 to 3 minutes, 24 hours a day, for 2.5 years. Jeff Drager admitted he thought the plan sounded crazy at the time. They did it anyway. The dam required 13 million cubic yards of material, translating to 22 million tons of rock. Barnard quarried every bit of it on site, eliminating the need for thousands of truck trips through surrounding communities and dramatically reducing costs. At peak production, crews processed 62,000 tons of material daily. The operation never stopped. Loaders, excavators, haul trucks, and rollers operated around the clock. The dam's profile follows classic engineering principles. The base spreads roughly 400 feet wide to distribute the enormous weight. As construction progressed upward, the dam narrowed. The crest measures just 30 feet across at 350 feet above the foundation. This taper creates stability, while minimizing material use at higher elevations, where working space becomes critically tight. Before placing any rock, crews drilled 2,000 grout holes up to 230 feet deep, totaling 28 miles of drilling to stabilize the foundation. They cleaned all soil and organic material from the bedrock, then installed a sand filter layer called Zone 5A. This prevents any sediment movement if water ever contacts the downstream side of the dam. The construction follows a zone system. Zone 4 material makes up the bulk at 11 million cubic yards of 24-inch minus rock pulled straight from the quarry and compacted. Zone 3 provides structural support. Zone 2 serves as a filter layer using 1.5 to 2-inch minus material that rests against the asphalt core from bottom to top. Zone 1 is the asphalt core itself, the impermeable barrier stopping water dead in its tracks. As the dam neared completion, space at the top became so constrained that Barnard switched from standard 740 haul trucks to Morooka tracked carriers. These machines can spin in place, drive forward to dump, spin around again, and return without reversing. When you're working on a 30-foot wide platform 350 feet in the air, every efficiency matters. 2.5 miles south of the main dam, crews built a 40-foot tall saddle dam with a clay core, adding 27,000 acre-feet of storage capacity, a 30% increase. The reservoir will stretch 3 miles when full, covering 740 acres between the main dam and saddle dam. The sheer persistence of building something this massive, one truck every few minutes for years on end, demonstrates what modern construction can achieve when planning meets determination. But even the most meticulous planning can't predict everything buried in ancient rock. Routine water quality testing revealed something unexpected. The granitic rock quarried to build the dam contained uranium-bearing minerals. This discovery changed everything about the project timeline and created a challenge that persists today. Uranium occurs naturally in some of Colorado's geological formations, and residents experience small amounts of exposure regularly. The uranium at Chimney Hollow isn't dangerously radioactive, but drinking water standards set by the Environmental Protection Agency impose strict limits on uranium concentration. When the reservoir fills and water contacts these rocks, uranium will leach into the water through a natural geological process. The filling timeline shifted from November 20th, 24 to early 2026, while engineers evaluate mitigation strategies. The leaching rate should decrease over time, but nobody knows exactly how long the process will take. Estimates suggest uranium levels could exceed EPA drinking water limits for 5 to 10 years if water flows directly to communities without treatment. Northern Water faces several options. One approach involves diluting Chimney Hollow water at a 20-to-1 ratio by blending it with water from nearby lakes and rivers. Another option means building on-site treatment facilities before water leaves the reservoir. A third possibility distributes the water to individual providers who already have treatment infrastructure capable of handling uranium removal. Northern Water expanded groundwater testing around the site to ensure uranium isn't migrating toward nearby Carter Lake, which serves as a critical water source for the region. Engineers believe that filling the reservoir will actually help by diluting the uranium concentration in the small amount of water currently pooled at the construction site. Dam safety testing and monitoring will continue for the next 2 to 3 years, while mitigation strategies move forward. No water will leave Chimney Hollow until further assessments confirm it meets all safety standards. This unexpected complication hasn't derailed the project, but it has added complexity to what was already an ambitious undertaking. The uranium issue demonstrates why major infrastructure projects always include contingency planning and why patient, thorough problem-solving matters more than rushing to completion. Water security for 800,000 people demands getting this right. Water will enter and exit Chimney Hollow through the same pipeline using a valve house that controls bidirectional flow. Engineers couldn't run pipes through the dam because penetrations compromise structural integrity. Instead, Barnard blasted a tunnel through the mountain, allowing the pipeline to reach the base of the dam from the other side. This inlet-outlet structure sits at the bottom of the reservoir, and water flows in from existing penstocks that descend from higher elevations, carrying snowmelt through the Adams Tunnel. The multi-year filling process began in 2025, slowly accumulating water while monitoring uranium levels and dam performance. A 2,000-foot-long spillway provides emergency overflow capacity during extreme rain events, though it should rarely see water under normal operations. The spillway directs excess water to a downstream channel that connects to other reservoirs in the regional system. The reservoir's 90,000 acre-foot capacity equals 29 billion gallons, enough to fill 725 million residential aquariums. Water delivery to communities is projected to begin in 2027, assuming uranium mitigation strategies prove effective. The reservoir will provide 30,000 acre-feet annually to communities across Broomfield, Boulder, Larimer, and Weld counties, creating stability in a region where water demand increases every year. The project delivers remarkable value at approximately $6,500 per acre-foot of storage capacity, making it one of the most cost-effective water infrastructure investments in recent decades. Building everything on site from quarried rock kept expenses manageable compared to importing materials from distant locations. Once filled, Larimer County will manage recreational access to the reservoir. The quarry site will vanish beneath the water, leaving no trace of where millions of tons of rock once emerged from the earth. The reservoir will simply look like a natural lake nestled in the foothills west of Loveland. The Chimney Hollow Reservoir stands as proof that patient planning, innovative engineering, and persistent execution can solve even the most complex infrastructure challenges. What's your take on this massive project? Drop your thoughts in the comments below and let us know what impressed you most about the Chimney Hollow project. If you enjoyed diving into this engineering marvel, give this video a thumbs up and subscribe for more fascinating construction and infrastructure deep dives. Until next time, stay curious.